questions 21 through 25 on the 2006 grade 10 AMC 10A. How many 4-digit positive integers have at least one digit that is a 2 or a 3? 4-digit positive integers. So the first thing I want to do is figure out what is the total number regardless of any condition. Well, the first digit cannot be a 0. If it was, it would not be a 4-digit number. It would be a 3-digit number. So we can put any digit from 1 to 9. So that's 9 possible choices. The second digit can be anything from 0 to 9. So I got 10 possible choices. Similarly, 10 choices for the third and 10 choices for the fourth. And this is going to give me the total number of 4-digit numbers, and that is 9,000. Now let's talk about our condition. We've got to figure out how many of these 9,000 have at least one digit that is a 2 or a 3. Okay. I think it's easier to think of the opposite, which is how many 4-digit numbers do not have a 2 or a 3. There's no 2, there's no 3. So eliminate 2 and 3 from our conversation. So that leaves the digits 1, 0, 1, no 2, no 3, 4, 5, 6, 7, 8, 9. And I've got to make 4-digit numbers with just these guys. Okay? Then what I'll do is I'll subtract this number, whatever it is, from the 9,000, and that will give me my answer to this question. Okay, so in a very similar way, I've got to make a 4-digit number. The first digit cannot be a 0, but it can be 1, 2, 3, 4, 5, 6, 7, any of those 7 numbers. Okay, so I got 7 choices there. The second digit can be any of these. So how many? I've got 8 choices. Third digit can also be any of those, and the fourth digit can also be any of those. So 7 times 8 times 8 times 8, and that is equal to 3,584. Okay, so these represent all the numbers that are 4 digits that do not have a 2 or a 3. So I subtract that from the 9,000, and that will give me all the 4-digit numbers that have at least a 2 or a 3. And that is equal to 5,416. And that's the answer to number 21. So 21 is E. 2 farmers agree that pigs are worth $300 and goats are worth $210. When one farmer owes the other money, he pays the debt in pigs or goats with change received in the form of goats or pigs as necessary. For example, a $390 debt could be paid with 2 pigs and 1 goat received in change. What is the amount of the smallest positive debt that can be resolved in this way? So it's an interesting way of paying for things. So let's just first to talk about the example they give us in the question stem. There's a $390 of a debt, right? So what they do is they don't have the money, so they exchange pigs and goats. So what happens is one farmer says, okay, look, I'll give you 2 pigs, and that's $600 basically. And the other farmer says, okay, well, I'll give you 1 goat, and that's $210. So in mathematics, that's 600 minus 210, and in their language, it's the debt, $390. So it's a cool little system that they have. Now, what they're asking us is that, sure, we did this for $390, but what's the smallest number that you can do this for? And what I did is just kind of looked at the answer choices and created mathematical formulas for each one. So the first one basically means that $5 would be equal to some number of pigs. I represent the number of pigs as P. Subtract by 210 times some number of goats, and I'll represent goats as G. Well, can this happen? And the answer is no, because if you subtract 210 from some multiple of 210 from some multiple of 300, you're never going to get a 5 as an answer, right? You might get a number that is a 10, like, you know what I mean? But You'll never get a 5, so this is a dud. How about 10? This seems promising at first. You say, okay, this looks like it might happen. But if you fiddle around with this, you will actually see that, unfortunately, this doesn't work either when you plug in different values for P and G. So that's all this is, really. It's just kind of fiddling around with the numbers. But the good news is, very quickly, you'll see that the next one works. And it works when P is 5 and G is 7. So when you got 5 pigs and you've got 7 goats, this becomes 1,500 minus 1,470, and that is indeed 30. So that type of a debt can be settled with an exchange of pigs and goats. So number 22, the answer is C. Circles with centers A and B have radii 3 and 8 respectively. A common internal tangent touches the circles at C and D as shown. Lines A, B, and CD intersect at E, and AE is equal to 5. What is CD? So AE right here is 5. And anything else they tell us? Yeah, they tell us the radii. That's 3. And this is 8. Okay? So that means since AE is 5, this little guy right there has got to be equal to 2. So squeeze that in there like that. All right, where do we want to proceed here? I think I will draw a line that connects A to C and a line that connects D to B. I think that will help me. And since the line I drew from A to C is the radius, I should say, that's going to be 3 as well. And D to B is the radius, so that's 8. Okay, and then this 8 right here. And then anything else? I think that should be okay for now. The first thing I want to do is figure out CE. Okay, and that can be done with Pythagoras. So 3 squared plus CE squared is equal to 5 squared. And that means CE is equal to 25 minus 9, which is 16, and the square root of that will be 4. So there you go. We got 4 right there. And now they want us to figure out CD, so all the way from there to there. Well, CE I got 4, so I guess I now have to figure out what is ED. Okay, that shouldn't be a problem. I think this is going to be done with similar triangles. Because since these are tangent lines, these are right angles right there. And this is a right angle as well, since that's a tangent. And these are opposing angles, this one and this one, opposite angles. So those are the same. We'll just call that theta and theta. And therefore that third angle will be the same for both triangles. 90 minus theta and 90 minus theta on that side. So there you go. We've got 2 similar triangles. We've got this guy and we've got this one. Those are similar triangles, and therefore we can figure out our value for ED. So that means 3 over 8 using those 2 triangles is equal to 4 over ED. Okay, so cross multiplying, you get 3 ED is equal to 32, and therefore ED is equal to 32 over 3. And what is CD? CD is CE plus ED. CE we got as 4. ED we just calculated as 32 over 3. Now we add the fraction. That gives me 12 plus 32, which is 44 over 3. And there you go. Number 23, the answer is 44 over 3, which is choice B. Centers of adjacent faces of a unit cube are joined to form a regular octahedron. What is the volume of this octahedron? So here is the diagram of this question, exactly what they're asking. And we need to figure out the volume of this octahedron. Now, before I start labeling it, how do we figure out the volume of an octahedron? Well, it's two pyramids, right? One on top of the other. So it'd be 2 times the volume of a pyramid. So volume of octahedron is 2 times the volume of a pyramid. And the volume of a pyramid, the formula is 1/3 times the area of the base times the height of that pyramid. All right? So here we go. Now the first thing, of course, we have to figure out the dimensions. Now they tell us it's a unit cube, so that means from top to bottom like that, all the sides are 1. Okay? Now, the first thing I want to do is figure out this length right here on the octahedron. Now that one we can figure out pretty quickly using Pythagoras. I'll draw it on the side here to avoid making the diagram messy. If I want to figure that side out, it will be using Pythagoras. And if you look at it from a bird's eye view, it will look like this. I'll just call that side X right there. And this is my X. And now the sides are going to be like this. Okay? Now, in a bird's eye view, it's a little bit more clearer. It's like that. And those sides are 1/2 each. All right? So very quickly we can figure out x. X squared is equal to 1/2 squared plus 1/2 squared. So that's 1/4 plus 1/4 is x squared. So that looks like 1/2 is x squared. So x is 1/√2. All right? So 1/√2 is the side of the base of this octahedron. And if you look at the base from a bird's eye view, the base is essentially a square. So that means that base looks like this, with each side being x, and we just figured out x is 1/√2. So if we go back to this formula, 2 times 1/3 times the area of the base, well, the area of the base is just going to be x squared, which is 1/√2 all squared. Okay? Now we have to figure out the height. So the height is represented by a distance like this, from top to bottom like that. Well, the good news is that height is very easy to figure out. It's just half the total height of the cube. The height of the cube was 1, so the height of that pyramid is 1/2. So there you go. That is your formula. And let's do it over here. So that gives me 2 times 1/3. 1/√2 squared would be just 1/2 times another 1/2. And this looks like 1/6. And that is the volume of the octahedron. So number 24, the answer is B. A bug starts at one vertex of a cube and moves along the edges of the cube according to the following rule. At each vertex, the bug will choose to travel along one of the 3 edges emanating from that vertex. Each edge has equal probability of being chosen, and all choices are independent. What is the probability that after 7 moves, the bug will have visited every vertex exactly once? So let's draw a cube. So here's a cube, and let's label it. Let's label the vertices. Let's just give them letters: A, B, C, D, H, E, F, G, H. So like that. And let's start discussing this question. So we're going to start, of course, at A. And from A, we have three possible ways of going. We can only go to a vertex that's, attached to the original point. They explained that in the question. So from A, I can either go to B, I can either go to C, or I can go to D. So from A, I can either go to B, C, or D. Okay? So that gives me three possible choices. Now I'm going to choose one of them to kind of explain this, but the explanation, it holds true for every other possibility. From A, let's say I chose to go to B. So I was here, now I'm here. Now once I get to B, where can I go? I can't go back to A, because if I did, there's no way I can reach all of the vertices. I can only go to either C or F. So that means from B, I've got only two choices, either C or F. So my number of choices is 2. And then let's say I go to C. From C, where can I go? Well, at this point, the choices narrow down pretty quickly. I can only go to G here, or I can go to D right there. Now, when I get to G, there's only one possible path at that point. It's F, E, H, D. F, E, H, D. If I do that, I will reach all the vertices in 7 moves. All right? Now, when I go to D, let's say I chose to go to D here. So now I'm going here. If I go there, then I've got 2 possible ways of moving in order to reach all the vertices. One path is H, E, F, G, and the other path is H, G, F, E. So as you can see from C, there's really only 1, 2, and 3 possible paths. And now what you do is you multiply them. We have 3 up here, we have 2 there, 3 here. So the total would be 3 times 2 times 3, which is equal to 18. 18 possible ways that I can reach all 7 vertices with 7 moves. Now this question is a probability question, so that means I've got to figure out a numerator and a denominator. The numerator is what I actually just did there. Now the denominator is the total number of moves. The total is going to be as follows. There's 7 moves, right? 1, 2, 3, 4, 5, 6, 7. And each move, you've got 3 possible choices. Like if you start at A, at the very beginning, you can go to B, C, or D. And then when you get to B, you can go either A, C, or F, right? This is the total possible, regardless of our outcome. So for each of these, it's 3. Every time you get to a vertex, there's 3 ways you can move, according to the question stem rules. So that is essentially 3 to the power of 7. So there you go. That's our probability. Now, of course, we got to get this into a fraction. So that is equal to 18 over 3 to the power of 7, which is 2187. And then 18 over 2187, I believe you would have to divide by 9 to get this in lowest terms. And if you do, you get 2 over 243. So there you go. Number 25, the answer is C.